CAMBOX is the last one of these linked moves, and in this one you've got the ability to basically design your own profile. So there's a cam with a cam follower, if you like, and that red curve is with the position. Actually, that is the position curve of that cam shape that you can see there. If you wanted to simulate that with a motor and a screw, it would look like that, but I don't think many people would design a system to pretend to be a cam in that way. It's quite artificial. But you can basically do any shape you like. This is just a fairly straightforward sine equation shape, but there are all sorts of, you can, let's say, do what you want with it really. The example that's used as a little motion example in this is feeding plastic film through some rollers, where you don't want to snatch it because you want a fairly soft curve to prevent the material from stretching when you accelerate it. If you just use a trapezoidal profile, then you will end up either stretching or tearing the material. So you might want to design some whizzy cam to do that. We've got some software built into Motion Perfect for designing cams, fairly straightforward ones. What the controller needs in terms of an actual input of the cam shape is a set of table data. So you see the table data on the top left there. You can either do that yourself externally in a spreadsheet or through mathematical equations, or it doesn't really matter where the data comes from, but in the end we need a set of position points starting from 0 and ending with some value. That one ends in the value 100. It doesn't really matter what the final value is, but it just has to represent your shape. The cam generation software in the controller basically comes up as it's in like your programs. When you do programs new, you can choose a cam profile as your program type. It's not strictly a program type, but it does allow you to choose different cam profiles. This particular one, you can see the velocity curve is that hump there. The actual data in the table is the green curve there, which is the position curve. Okay, so that's actually what goes in the table there. But people often like to think in terms of velocity rather than position. So you take your cam data that you've got, your shape that you've made, and you put it into either a cam command or a CAMBOX command. There's two types of this. The cam command is like a move. It'll just execute that data path through those points over time. So you just simply need to tell it where the table starts. So in this case, table 0, where it ends, which is at 47, 48, 50. So the first two parameters would be 0 and 50, and then the multiplier here. That's applied. The cam and CAMBOX are like the connect. They operate in encoder counts. So the final position of the movement will be the end position in the table multiplied by that multiplier. So in this particular example, if it started at 0, it would end at, in encoder counts, 100 times 87.5. So it would be, what's that, 8,750. So depending on what that represents in millimeters, that would be the end point. There's a way around sort of this kind of arbitrary way of scaling it, in that if you know your units as a certain value, so in this case you've been using units of 50, yeah, in our little examples. If you make your cam profile in the table start at 0 and end at 50, that whole table represents 1 millimeter. So then your multiplier there would be in millimeters. So you can actually make it more human usable in that way, simply by making the cam represent whatever it is you've got, whether it's 1 millimeter, 1 revolution, 1 inch, 1 foot. That's through Motion Perfect. So I'm in sync mode, that's okay. So if I go to Programs New, then I'm going to go Cam Profile there, call it Cam 1, and that brings up that window like that. And then you simply choose what sort of cam you want. So this here, called an offset sine curve, you can kind of get the different types there. So you've got one which starts at 0 and has a period where it runs at 0 and then does a sine kind of acceleration hump there. One that starts at a non-zero value, so the ratio to begin with is above 0 and has a similar shape on it. One which is starting at non-zero, has an acceleration and a constant ratio part at the top and then decelerates again. You may recognise that one. That is exactly the same as a flex link. Yeah. Before we invented flex link, you had to generate a cam like this and then run CAMBOX. So you had a two-step way of generating that kind of motion before we did the flex link. But the flex link does all of this internally. And then the last one is a piecewise curve. This is where you can put your own points in, so you can enter data as you want with that one. And I can never really quite show that well enough to make sense of it.
How many points what's the maximum number of points you can use?
You can fill the whole table actually. There's 512,000 table locations, so you could have a cam with 512,000 points in it.
Yeah. It's based on the color resolution and
yeah.
the distance you want to do.
There's not a lot of point in having that number unless you've got a move that takes 512,000 milliseconds. So 512 seconds to complete the move, because you'll only get 1 point per millisecond anyway.
Yeah. And that's the total memory space for cams.
That is the
total. Multiple cams.
Yeah.
Then you would have to divide it by the number of.
You need to divide it up. So, and the other thing to say is that when you see this table that you've got here, this has got 100 points in it. Okay. So if I make a move that takes 100 milliseconds, it will use every point. Yeah. So it will be exactly the shape you do. If I make a move that takes a second, it will actually use all of those points, but it will do a linear interpolation between each one. So it will fill in all the in-between points for you using a linear interpolation. If I make a move that is less than 100 milliseconds, so say I did one that takes 20 milliseconds, it will still do it fine. All it will do is it will pick out the points it needs from that table. So there's no restriction on you needing to put in an exact number of points to represent the time taken in your move. You can just put in enough points to make a reasonably shaped curve, and then the maths in the controller will take care of everything else. So it's a very, very easy to use really. There's no big restrictions on the number of points you have. The minimum would be 3, but that would be 2 straight lines, and the maximum, as I say, is the whole of the table. But it doesn't make any sense to use that much memory for a fairly simple straight. In the
and can you click to define them directly in that graph? You can basically just literally.
You can if you've got the points. It'd be easier for me to show with one of the others. So if I go to that one there. So I can initially set up how much of this I want to use. So I could say, right, I only want 10% coming in and 0 going out or something. So I've moved. So you see there's a flat spot there on the first 10%.
Now you can move the points.
And then I can then move the points. So I've got 101 points in that. Distance is 100. So like I say, if I knew my units was 50, if I make that 50, then everything in the cam command is in millimeters, because I've made my table go from 0 to 50. And if you look at the code, there it is, 0 to 50. It's going up to that 50 value there. So this one's a fixed shape. Okay, so let's just go back to the piecewise one again, because this is where, I know what you're asking. So we've got 2 points in this at the moment. So if we adjust that by adding some more points, like that. Okay, so we've got a load more points in there. So now I can drag them around if I want to. I should be able to. Maybe I just need the finger to do it. So I can change the shape like that just by dragging the points, and you can hopefully see they're changing in the table as well. The position points, and you can see the speed value is kind of wanging up and down. So to get it smooth, you'd have to try and make it so the speed transitions were relatively smooth as well. That's the acceleration. So kill the other. So that's your acceleration curve at the moment. And again, you can try and play with that to minimise some of those, if that's possible to do. It is calculating some kind of spline interpolation to do this. Goodness knows what's that done to the position curve now.
A system where you could actually manipulate the acceleration itself. That's quite clever. I thought in the past I've had to change the position and then
look at the acceleration, right? Yeah.
Yeah.
It's rippling about a bit, isn't it? There. Okay, the options is just about colorization, really. Yeah, so that's how you get the data anyway, and then from that you get the table that's been generated. At the moment, you would copy that from that part and paste it into a program. That isn't a program in its own right. So you've got a copy to clipboard thing here, so you can copy that and then paste it into a program. And then that's used within the program then. So once you've done that, you then need to use it within the particular command that you're going to use. So going back to the cam, you've got your shape in the table, but it actually applies that over a time, and the way it calculates the time is basically from that distance parameter. So that last parameter called distance, don't get confused, it's not the distance moved on the axis, it's a distance parameter used to calculate time. So based on the distance there and the speed value of the axis, which you can see there is 250, this will take 4 seconds because 1000 over 250 is 4. So that's simply what it's used for. The cam is like layering this table values over the top of a constant speed move internally. That's kind of what it's doing, and that constant speed move is moving at the speed value given there, and then the distance you put in the cam command is the distance it will travel over internally, but it's not a real distance at all. The real distance is the one covered by the points in the cam. Yeah, the PowerPoint says everything I just said. CAMBOX is the linked version of that, so it's the same thing again. Table start and end, multiplier, exactly the same. This time there's a link distance, so it works like the move link. So it will follow master axis over that given distance of the master axis. Okay. And this little example of feeding some rollers when a cutter is in the up position, essentially basically follows the cutter axis over the top 180 degrees. So when you see the program, you'll see that the link distance is 180 because it's 180 degrees of that, and it have the link axis. It also have a starting position, the starting position being 90 degrees. So if that's 0, bottom dead center, it starts there and does it over that, and then by the time it's there, these rollers have stopped again, and that's stopped, and then the knife can come down to do the next cut. And this is one of those PowerPoints that goes step by step. So there you are, there's the setup. Again, you're setting 360 degrees for the cutter, so it's 1 revolution. And we're setting up registration to find the home sensor, or the Z mark in this case. It's doing a little bit more than 1 turn, move 400, just to be sure, just in case you started at, you were actually on the mark when you start, so make sure it actually finds it again. So it finds the Z index on the encoder, and then if it does find it, does an off pos to set the 0 position of the axis, and then starts a forward to start that cutter going up and down, and then the bit that does the actual movement is just those 4 lines in that repeat loop. So it's doing a CAMBOX following table locations from 200 to 250 of the length you want to pull, 180 degrees of the master, starting at 90 degrees, and that's it. And again, like a lot of these programs, the actual bit that does the motion is fairly small. The rest of it's all set up and control really on top of that. So I can see you're quite keen on possibility of using
Yeah.
cams and putting your own things in.
Yeah.
Yeah. If you do it on a larger scale,
Mhm.
you just got to remember that in between each point it's a linear interpolation. So we
Yeah.
will do, you know, if you have 2 points and it takes you 2 seconds to go between them, it will follow them in a straight line. And sometimes if people want to do more complex coordinated moves based on torque points, you can actually run 2 or 3 or 4 CAMBOXes all following one virtual master.
Yeah.
So they would all follow together
Yeah.
along one virtual master, and then everything will work,
Yeah.
you know,
Mm.
repeatedly in a coordinated way. So you can repeat the same thing or move something slightly, you know.
Mhm.